do this business. Short term, they enhance LTP. Short term, they enhance dopamine release. Long term, they do just the opposite. How does that work mechanistically? The trick was sorted out about a decade ago. There's two different classes of glucocorticoid receptors in those parts of the brain, one of which works real fast, one of which works slower. So we see there this very interesting contrast between short-term stress and long-term stress, and between what happens in one part of the brain and another. Meanwhile, there's a very interesting other neuroendocrine interaction with LTP. Estrogen turns out to enhance LTP in the hippocampus. You get an unusual response, stimulate the neuron like crazy, and when there's estrogen on board, you get a vast potentiation of the potentiation. Estrogen makes LTP occur more readily. Now, these same themes continue at the next level. We already know a whole big aspect of the story. The neurons, there's these 10,000 dendritic spines and the axon terminals, and it turns out this is a very dynamic, plastic process. You use the jargon from earlier lectures. And what you wind up seeing is different types of events, experiences can cause neurons to grow more elaborate dendritic branches, can cause them to shrivel up, and you see the exact same thing here. Chronic stress, chronic glucocorticoids, and those dendritic branches in the hippocampus shrivel up. What's the consequence of that? That's straight out of the network lecture. What you're doing is you're disconnecting networks, and that's sure going to disrupt things. It's bad enough if you've got a synapse, which thanks to chronic stress is not doing LTP very well anymore. It's even worse if you're ripping that synapse apart because your dendritic spines are shriveling up. Chronic stress, chronic glucocorticoid exposure causes atrophy of these dendritic arbors, these dendritic branches throughout the hippocampus. And you guessed it, meanwhile, next door in the amygdala, not only do glucocorticoids enhance LTP, glucocorticoids stimulate amygdaloid neurons to grow new branches. And that's part of that story again about why the amygdala is this hyper-excitable part of the brain with anxiety disorders, with post-traumatic stress disorder. Next, just like the LTP story, along comes estrogen, and what estrogen does is stimulate hippocampal neurons to grow new processes. Aha, so you were sitting there and saying this generates all sorts of predictions. When estrogen levels are high, hormones working in the hippocampus, estrogenic hormones cause hippocampal neurons to grow new processes for synapses to work with. Does that mean that learning and memory gets better when estrogen levels are high? Absolutely. That is shown in humans and all sorts of circumstances naturally over the course of the ovulatory cycle. It is shown in humans where hormone levels are manipulated for any number of reasons. It's shown in laboratory rats. Here's how amazing the effect is. In a laboratory rat, just as we heard in the very first lecture, as we passed through various proteins, there's a 4-day ovulatory cycle. Every 4 days, estrogen goes up, goes down, ovulates, that sort of thing. It's a 4-day cycle, as opposed to the 28-day one in primates, humans. And what we got with is this amazing phenomenon over the course of this